In today's session, we will learn a little more about the other components that involves the security for the VPC. So as part of this, I'm going to be introducing you about network access control list, NACLs, and security groups. So we'll understand what are these components about, and let's get start using them as part of the provisioning. So just to give you an idea about the NACLs and security groups, let me just right. Can you make the screen bigger a little bit? How about now? Is it much better? Yeah, right. So if you just look at the yesterday session, in yesterday's session, I have introduced you about VPC, the subnets that are governing the VPC. So let me go back to the yesterday session. So I picked up a VPC and then I spread to do different zones, zone A and zone B, where I had public and private subnets. The same thing was copied across different zone where I had placed my web app servers. And then I made sure that the subnets do take a route with the help of the routing tables. Public subnets taking the route with the involvement from the internet gateway, and the private subnets are taking the internet route via the NAT gateway. So now from here onwards, we'll focus a little more about the subnets, what kind of traffic they'll allow and what kind of traffic that gets blocked. So there are few points that you guys have to remember, that source and destination. This is very important. Where does the source come from and where is it thus the request will go back? Let's say I'm outside the internet, I'm outside the VPC, somewhere on the internet. Now I have to access certain data from my server. Let's say this maintains information regarding employee table. So I want to list the database of all the employees who are particularly belonging to a department of, for example, development. I want to look at the data who are part of the development. So I'll write select statements to get the data. So here the request will go via the internet gateway, allow me to reach to the web servers, application servers, go and fetch the data from the database. It gets the results sent across to the data, and from there I will be able to receive my request will get complete. So this is my request and I'm getting the response for it. So then my request is complete, and for that I have a corresponding response. So my complete task is done, transaction is done. So the point is, where is the request coming from? That is what is the source. So it is coming from where? From internet. Sorry guys. So the request is coming somewhere from the internet. Sorry. So when the request starts to come somewhere from the internet, so in that case, source for your subnets, which are public subnets, becomes internet. Clear, people? And the request gets processed and sent back to me, and that is like I receive my request back. For the response that I gave, for the request that I raised, I am getting a response. So I'm somewhere on the internet. So in this case, for the public subnets, that is 1.0 and 3.0/24. What is the source and destination? So people, I can say it as internet. So because the request comes from internet and goes back to internet because I'm available on internet. The question to all of you is, then what is the source and destination for the database instances or for the instances which are 2.0 and 4.0? Can anyone respond me that what would become the source and the destination for the private subnets? Absolutely right. So the database is not going to interact directly to the outside world. So database now has the source originating from 1.0 and the destination going back to 1.0. If 100 there, 3 is already applied automatically. So the source and destination for 2.0 or 4.0, which are the database instances or private subnets, they receive traffic from 1.0 and 3.0, and the destination is 1.0 and 3.0. So guys, do one thing. Just ignore this one for a minute because whatever that you apply for 1.0, 3.0 is already applied. 2.0, replica of 4.0. So here the point is, what is the source for the database? 1.0 public subnet. What is the destination for database? 1.0. So both source and destination are 1.0 in this case. People, are you clear with this idea now? Once you are clear with the idea of source and destination, that is where the traffic management will come into picture. So what is this traffic management is all about? See, when something is getting exposure to internet, when something, a resource, web server, app server, or whatever the servers that get exposed to internet. So we don't have a control across what kind of traffic that it brings or where does it originate from. It can originate from any part of the world and it can reach. So there is a lot of risk involved. There is a lot of vulnerability for your machines. Your EC2 instances can undergo a lot of risk because it is directly getting exposure to internet. So now what we have to do is we need to write certain rules that what kind of traffic that you want to allow and what are the type of traffic that you want to block, what type of traffic that you want to allow and what is that you want to block. So those rules are written in the form of firewall settings. So these firewalls can be achieved in two methods. Method number one, or the firewall settings when you write at a subnet level for your public subnets, we call them as NACL. When you write firewall settings to allow inbound and outbound traffic at the subnet level, we call them as NACL. When you target allowing the traffic, that what type of traffic that you want to allow and what type of traffic that you want at the instance level, then that is what we call it as security group. So the simple difference is both of them play the role of firewall, that is managing the internet traffic, but when you apply the changes to allow what kind of traffic that you want to manage, allowing what traffic to allow what to block at the subnet level, these firewall management we call it as NACL, network access control list. If you get it done at the instance level, we call it as security group. So people, can I have a quick confirmation in the chat window that you have understood a simple difference between NACL and a security group? So NACL act like governance for allowing internet traffic, what type of traffic to allow, what type of traffic to block at the subnet level. Whereas the security groups act like firewall at the instance level. So let me just show you in my architecture. So there is a public subnet which is 1.0. There is a public subnet 3.0. You can see there's a green color dotted line which is governing the subnets for your public subnets, which is called public NACL. There is 2.0 and 4.0 subnets, which are private subnets. The private subnets are governed by a red color icon, dotted line, that is governing your subnets. So these NACL will allow what kind of traffic should flow into your subnet, because we are maintaining NACL as a firewall at the subnet level. So subnet is now governed by NACL. Now NACL will manage what type of traffic to allow to the subnets, what kind of traffic that you should block to your subnets. So I'll try to give you a simple analogy, guys. I hope that analogy can help you to understand things much better. So take up a building. It's a big building and there are different flats in it. Sorry for the diagram. So the different flats in it. So the first floor, second floor, let's assume that there is a 10-story building. And there are about 100 flats, which each floor comprising of 10. So there's a common security which is governing all this flats. So let's say you are visiting 504, fifth floor, 504 is an apartment that you need to visit. So the point is, there's a common practice for the entrance. There will be a check and there will be an exit and there will be a check at that exit for the person who walks in and walks out. Let's say you are a guest visiting apartment 504. So the security which is at the entrance will have a check saying that what was the purpose for your visit. So you'll make some entrance at the at the entrance you'll give the all relevant information, and then once your job is done you'll do an exit. So NACL does the same thing. NACL have the same purpose. The purpose of NACL is to make sure that you'll allow the traffic, which is acting like a security at the common entrance. So NACL also act like security at the subnet level, making sure what to allow and what not to allow. If you don't have a purpose to visit 504, then security won't allow you to do that. Whereas the security is like once you reach to 504, if you're visiting for the first time, so then you will be checked at the security at the door, like who exactly or what was the purpose for your visit. Then try to identify the person, who are you, because that's the first time that you're meeting up. So this kind of traffic that is governing at the subnet level, where subnets are like different subnets that I have, I'm corresponding to the different flats now. It's a common NACL. Now you're only authorized to visit 504. So you're not allowed to visit any other flat. So now this kind of governance, if I can bring it the instance level, then that it can be done using security groups. I hope now clear, people, the idea of security groups and NACL. Clear? Right. So when use that, your request will become complete when you make an entrance successfully, visit 504, get your job done, come from 504 outbound, then you leave from the exit. Now, if you are blocked at the exit level, if your clearance is not okay, then you will not be allowed to exit because they felt that you don't have any kind of proof to show that there was a valid reason for your entry. So my request will not. So the point I want to bring is, for a successful transaction to happen, my NACL should allow me, my security group should allow me, and then my NACL outbound should allow me as well. Clear, people? So the security settings, the firewall settings, the type of firewall setting that you enable at a subnet level, we call it as NACL, whereas instance level, we call it as security group. So now you can see this is instance, and the blue color, violet color line that is governing your instances. For your web servers, you have a web server security group. For your database servers, you have a database security group. Clear, people? Because the traffic that comes in via your subnet has access to every instance. So I want to block what kind of traffic that is reaching to your subnets. I should have a control on my instance. I should not allow all the traffic to instance. Let's say the traffic that NACL is allowing every other traffic. Let's say there are about SSH traffic, HTTP traffic, RDP traffic. I'm allowing different protocols for the traffic to come in. But I don't want all the traffic to hit my subnets. I want only specific traffic to hit my subnet. So let's say my NACL allows everything, every traffic it allows. But I don't want all the traffic to reach to my web server. I want SSH traffic, HTTP traffic, and RDP traffic is the only traffic that I want to allow. For those people who don't know what is SSH, HTTP, RDP, let me put them in line for you. So SSH is a protocol. If a machine is a Linux machine, if a machine is a Linux machine, or if a machine is a Windows machine, there are some protocols that we need to follow to connect that. So SSH is a method of connecting to a Linux instance. For that, we have to open port 22 for that machine. Please do remember it. Likewise, RDP, Remote Desktop Protocol, is a protocol that is offered by Microsoft to connect to your Windows server, and the port number to be opened is 3389. If these servers are routing any kind of traffic that should be accessed over port 80, then the protocol we'll use is HTTP port 80. So if my NACL allows every traffic, all the traffic it allows, but I want to make sure my security group should allow only these 3 units of traffic, like SSH traffic, assuming that that machine is a Linux machine, so I need an SSH to be done. Or else if that machine turns out to be a Windows machine, then I need to do an RDP for that machine, or I need to make sure that they receive HTTP traffic for port 80. So the same settings, guys, will achieve now inside the console. So before I go ahead and start attempting it, I want people to start remember the protocols. SSH protocol is an port protocol which is running on port 22. RDP is a very much well-known protocol for Windows, which is 3389. HTTP traffic requires you to HTTP 80. HTTPS traffic requires you to open protocol 443. You'll come to know all this even in the console. Anything with regards to databases like MySQL, we need port number 3306 to be opened. If it is MS SQL, Microsoft SQL Server, Try remembering the ports 1433. If you can remember, that's good. If you don't, you can learn it from console. Try remembering these numbers. This is very important for you. So people, quick summary of what we have learned. We are focusing now on the flow of traffic. What kind of traffic that you will allow into your subnets, and from subnets to instance. What kind of traffic that you will allow into your subnets, and from subnets into your instance. So these traffic governance is done in the subnet level as well as an instance level. When you are allowing traffic to flow through your subnets, then the type of traffic, firewall management, we call it as NACL, network access control list. Whereas you are allowing the inbound and outbound rule traffics, which you are writing at the instance level, we call it as security groups. Clear, people? Can I get a quick confirmation in the chat window so that we can proceed further and launch inside the console? Okay, so let me make an attempt, guys, to write those kind of security groups and NACL. So let's get started with NACL. In yesterday's session, I've shown you when the VPC gets created, it gets created with the default NACL. And the NACLs are written in the form of rules, which are inbound rules, what kind of incoming traffic you will allow, outbound rules, what kind of outbound traffic that you will allow, and what are the subnets that are associated. It's as simple as that. When you don't attach your subnet by default attaches with the default NACL, because that was created by VPC wizard. When I have created yesterday VPC, you should have noticed that in yesterday when I created a VPC, a default NACL got created, and all of the subnets are associated with. Let's look what is the traffic that is allowing. So rules are making the traffic to flow in and flow out. In that, you see an inbound rule. What is the kind of inbound rule? The kind of inbound rule, it clearly says the rule number is 100. It's just an entry. What kind of traffic? It says I'm allowing all the traffic. Okay. What are the protocols it is allowing? All the protocols. Very good. Port range, from every part of the port. All the ports are allowed. Where does the request originate from? Internet. That is what is source. What is the statement? Allow. That means when you look at the inbound traffic, that means what is the incoming traffic? What does the rule will allow? All the traffic from all the ports, the inbound traffic is allowed. May I have a quick confirmation, guys, in the chat window that you have understood the idea of statement allow. Inbound rules allow all the traffic at all the ports. Where is the request coming from? Anywhere from the internet it can originate. So my default NACL inbound rule clearly allows everything. There is no restriction that I have a control on what kind of traffic that I want to allow. Let's look at the outbound traffic as well. Since the request get originated, the request should go back. Where did it got originate? So now, is it allowing? Rule number is 100, allowing all the traffic, but all the protocols, all the ports send back to the destination wherever the request getting originated. Yes, destination source means where the request is getting originated from internet. So where does it get originate? Internet, and it will go back to internet. Internet means any IP address over that internet. And what are the subnets that are associated? All of your subnets are associated. So all the subnets, because of this default NACL, will receive all the traffic at all the ports at all the protocol. Likewise, the outbound traffic also send the traffic from all the ports, from all the protocols. Allow. Clear, people? Very simple. Default NACL. Okay, let me make an attempt that if default NACL is something that you're looking for, can I write my own NACLs? Yes, you can go ahead and write NACL. Let's say I want to write the NACL subnets for my public subnet. So I'll write it public NACL. What is a VPC that I have to my VPC? 87C, the last three numbers, and go ahead and create it. Okay, let me create another sub NACL which is targeting my private subnet. So private NACL for my VPC targeting my private subnets. Let me put even the name VPC. So now I have two NACLs that are created for my private subnets and public subnets. Can we attach single subnet to multiple NACL? That is what we will see now. So now you can see by default, when nothing is associated, all the subnets by default are getting to the default NACL. So let me make an attempt to attach this subnet, like the subnets that I have. Let's say I want to attach for the public subnet. I said public NACL. I should be associated with the public subnet. So what are the public subnets in this case? One is a public subnet and other one is 3. And edit it. So from this point, you can clearly learn that your subnet cannot spread across multiple NACL. That means your subnet can be only attached with one NACL only. That means when you have a subnet like public 1.0, it can only be associated with only one NACL, either public, private, or default. If nothing goes by, it will go to default. See that a subnet which is 1.0/24 cannot spread across multiple NACLs. So can we attach single subnet to multiple NACLs? The answer is very much no. We can't attach our single subnet to multiple NACLs. But NACL can get attached to multiple subnets. You can see two subnets, public subnet and another one is public subnet 1.0 and 3.0. But a subnet like public subnet 1.0 can only be attached with one subnet. So let's look then what kind of inbound traffic it is allowing, what kind of outbound traffic is allowing. So inbound traffic, if you look at the inbound traffic, we look at the no rules at all. See, there are no rules, no network access control list. Very good. Outbound rules, no rules, NACL rules. So people, what is your learning from this? When you go beyond default NACL, NACLs block everything. It doesn't allow any kind of traffic to flow in, any kind of traffic to flow out. Whereas default NACL allows all the traffic at all the ports, allows all the traffic at all the ports. Whereas a customized NACL, custom NACL allows nothing, no traffic at all, zero traffic at both inbound and outbound traffic. So can I customize as per my requirement? Yes, people, you can go ahead and customize it. So let's say I want to allow, I'll write the rule number 100. So please allow me traffic for HTTP where the request can originate from internet. Okay, and I'll do a save. So now people, can you notice that your NACL, which is public NACL, can only allow traffic coming from HTTP, which is HTTP from internet. That means someone wants to do an HTTP from the internet using public NACL. The answer is yes. Let's look outbound rule. So clearly you can see there are no rules that are allowing traffic. You guys understand in this way, in this context. There is a server. Where is it attached with an NACL? And there's a HTTP request that I'm making. This is the inbound traffic that HTTP request comes up over port 80. This is my request that I'm sending to, and the server need to respond back over the same port 80. Now I need to get a response. So when a transaction will complete for a request, there is a response. There should be a response. So for there is a request, there is a response for me for port 80. So he can clearly see my NACL that I have just now gotten, the NACL, default NACL. It is allowing inbound traffic. But what about the outbound traffic, guys? So will my request be complete? People, will my request be complete if inbound rules are allowing traffic to flow in, but the outbound rules are allowing traffic to flow out? Clearly, you can see here the inbound traffic is allowing me to do HTTP requests from internet. But when I go back and look at the outbound rules doesn't have anything. That means what should I do now? We should go ahead and even write a rule saying that if you want, you can write any number. But now, just for similarity purpose, even I'll go ahead and write HTTP traffic. Okay, go back wherever the request got originated and allow. Save. So now you can see there is a corresponding inbound traffic and there is a corresponding outbound traffic. For every request, there is a response. Like, just visualize the idea of the common security, guys. So for every request, if someone walks in for a request, when is that request will be complete? When he makes a successful exit. If he doesn't make an exit, that means he is still in the building. My request is not complete. When your request is complete, when you go into the building via the common entrance, get a clearance at the exit, finish your job and make an exit from the exit mode. There's only one exit and one entrance. So you make an entrance into the system via the common entrance, get a security clearance, and then you get your job done at the apartment. Once the job is done, you have to make an exit from the common entrance, that is common exit. So your request will be complete when you go and come out. That means you should have both the rules written for inbound and outbound traffic for NACL. If I don't have outbound traffic, that means my request is not complete. People, can I get a quick confirmation in the chat window that you have understood the simple idea of using non-default NACL, which by nature denies everything until unless you go and allow what kind of traffic that you want to allow and what kind of traffic that you want to block. Clear, people? So the nature of default NACLs, you can clearly see it allows everything. So there are no issues with the default NACL. It allows everything. Inbound traffic allows everything, and the outbound traffic, no problem with the default NACL. But the challenge that I'll face is if I'm not using any default NACL, then non-default NACLs will come into picture. Their nature is they block everything. When you don't allow anything, they block everything. So you have to go and explicitly allow what is the type of traffic that you want to allow and what is the type of traffic that you want to receive. Inbound and outbound rules for the non-default NACL. Clear picture, people? Now, to get even to make things much simplified, what I'm going to do is I'm just going to release them back into the default NACL. So now I have a public NACL and private NACL, which I'm not going to write anything into it. Let's continue using default NACL so that the default NACL allows all the traffic via the inbound and allows all the traffic to flow out via the outbound rules. So Rakesh puts me a question. Inbound means source to destination. That's right. What type of traffic that comes from source and reaches to your subnet. Outbound means destination to source. So instead of destination and source, it is inbound means where the traffic would originate and reach to your subnet. Outbound means where the traffic will go back from your subnet to the source. That is what is outbound. Outbound means incoming traffic. Sorry, inbound means incoming traffic. Outbound means outgoing traffic. So in order to take away the complexity, guys, my recommendation to all of you people, when you are getting started, please use default NACL. That means you will not make any change here. The point I wanted to bring was to give you an idea how does the NACL looks like. So my suggestion for all of you, try continuing using default NACL. When we require additional configurations at the subnet level, then I'll continue using non-default NACLs. Then I'll create my own NACLs, which we can ignore for some time. First, try understanding default NACL. Default NACLs allows all the traffic at all the ports from the internet, sends back from all the traffic back to the internet from all the ports and all the protocols. So that is what is the nature of default. Continue. Now it is the most important filtering will be done at the security groups level. So let me just go ahead and start using the security groups. So right now, security groups, as I mentioned, they deal with the type of security at the subnet level. So I'll filter by my VPC. Do I have any security groups? Right now, there is only one security group in my account, which is the default security group. So some relevant inputs regarding the name security group is default, the ID for it, what kind of inbound rules it is allowing, what kind of outbound rules it is allowing. Okay, let me give let me start writing my own security groups now. Now, whatever the type of security groups I need now, if you look into the architecture, I need a security group, which is web server security group. Why I need a web server security group? Because I want to allow my web app servers to govern the web server security group. So what I'll do now, I'll go into create security group, give a name for the security group as my VPC hyphen web server security group. This security group allows traffic from internet to reach web servers or web app servers. Clear, people? Why is that I'm creating the security group? To allow the traffic coming from internet to reach to your web servers. Which VPC? Inside my VPC. And just go ahead and create a security group. So now you'll notice that a security group got created with a security ID, the name of the security group. If you look at, there are two options once again, inbound and outbound rules. So now, what kind of traffic this security group is allowing people to your instance? Can you please let me know? Look at this. I'm using my VPC security group, which is web server security group, to my instance, and I want to see what kind of traffic that is allowing. So now the idea, what I want everyone to understand is, forget the idea of NACL. NACL are not a burden for us. Why? Because we are using default NACLs. So it is allowing all the import traffic, all the traffic it is allowing, all the traffic inbound and outbound. So forget about NACL. So NACLs are not going to be constrained for you. The idea to discussion, what to bring to a discussion was to let you know how NACLs work. That's all. But the question is very, very important for us is security groups. Now the security groups, the question is, what is the security or what kind of traffic is coming to your instance if you use this security group. So I use this web server security group now to my instance. Okay, and now I've created a web server security group. I'm gonna use this for my instance. Question is, in the current context that I'm showing you, what is the inbound traffic that is coming in? What kind of traffic that is coming in or allowed by security group? Look at the screen, guys. Exactly, there is no traffic, right? There's no inbound traffic. That means doing an RDP, things don't work. Doing an HTTP, things don't work. Doing an SSH, things don't work. That means your inbound rule clearly says no traffic. That means no traffic will reach to your instance. That means you should start now writing the rules for the inbound rules. So go ahead and click on actions, edit the inbound rules. So what should I do now, people? What kind of traffic should I allow now? Let's get started with first traffic, which is RDP, or I remember the pattern in ascending numbers like 22. So I need now traffic is SSH. Next, 80, port 80, HTTP traffic. Next, 3389, RDP. Now, where the request can originate from? Source. Where does the request can originate from? Of course, it will be from internet. No, 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 we don't want from internet. So, where do you want it? Only from this IP address. So, what is this IP address, guys? This is my particular IP. This is my public IP. That means I'm the only authorized, or my laptop is the only authorized system to do an SSH. Sometimes companies do have requirements saying that, okay, people will allow only to do an SSH from your particular laptop only. Sharath is the only authorized person to do an SSH, no one else. So in order to take away that complexity, let me say traffic can originate from internet, HTTP traffic can also from internet, RDP traffic also from internet. That means from any part of the world, I can make an SSH request, HTTP request, RDP request. And I go ahead, save the rules. Now, how many rules, guys, we are allowing? 3 rules. HTTP traffic to flow in, SSH traffic, and RDP traffic. Clear picture? A server is running with the security group with Jenkins as its software running on a port 8080. Can I access Jenkins with the security group with port 8080? Why no? And if answer is yes, why yes? Can I access Jenkins as a software with the security group, which is going to be needing port 8080? Exactly, people. Can you notice that port 80 is only defined, port 8080 is not defined? So what should I do now? Edit the inbound rules if I need. So I need traffic, custom traffic. What kind of port should I open now? Port 8080 should be open. Can I access now? Okay. Source, where the request can originate. For now, let's focus on internet. Guys, initially when you're practicing, try making sure that you'll allow port from internet. Once you become clear, you can restrict the port. So now Jenkins is a custom TCP traffic that is coming from port 8080 is open, anywhere from the internet can be accessed. Clear, people? Can I access Kafka, a messaging tool which needs port 9090 to be opened with the security group? Can I allow Kafka to be accessed over port 9090 with this security group. Can we change the port number? See, port numbers are some standard port numbers that we have to follow. Like HTTP is port 80, SSH is port 22, RDP is 3389. Sometimes we need to open some customized port for our applications. So at that time we can change the port. Let's say I will go ahead and change the port. But for standard protocols, no one can change. For standard protocols like HTTP, RDP, and SSH, sometimes we don't need port 8080. I need a port like 5439. So for an application I go ahead and change the rule. So now the application can be accessed over 5439. For standard protocols like HTTP, SSH, RDP, I can't change. Clear, people? Okay. My question to all of you. In NACLs, we have to have inbound and outbound rules. Now, should I take care of outbound rules as well, people, for the security group? Should I write outbound rules HTTP port 80, HTTPS port 443, SSH 22? It clearly allows everything as an outbound traffic. Why? It's little logical, guys. Just imagine you are a guest to my house or you wanted to visit me. So the same idea of common entrance, NACL, you got a clearance at the common entrance from the security. Then you reach to the flat number 504. I'm waiting for you. So I have identified you that you are the person that I want to meet. So I'll allow you to my room and we will spend time regarding discussion. Then you said the job is done. While about to exit, should I go and ask you, are you the right person to leave this premises? Very much illogical. So it is understood a person who walks in is the person to walk out once he get a clearance at the entrance level. So it's like who all are coming will go. That's a right statement. Whoever walks in, he has a right to walk out. But this syntax is not gonna be applicable at the common exit, because common exit is something that you have to have a clearance. So in a similar way, when you look at the inbound rule, guys, if the traffic of HTTP comes in, the traffic of outbound rules also allows the HTTP to go out. If a traffic of SSH comes in at port 22, the outbound rule automatically by this rule allows port 22. If no traffic is allowed in, then no traffic is allowed to go out. If the traffic of 5439 is allowed in, the traffic out outbound rule is allowed. So guys, my suggestion for all of you, for now, forget about NACLs. Focus only on security groups. So what is the learning towards security group that you have done? Security groups basically provision or provide the service in the form of firewall settings at the instance level. You are only concerned about one rule, which is inbound rule. You are not concerned about outbound rules. So if you have some issues while connecting the server, it is because of the inbound rules of your server. Whatever the inbound rules that you have, it is because of the inbound rules of your security group. Because outbound rules, no issues. Whatever comes in will go out. So what is the issue if you are getting some, let's say you're not able to make SSH? That means security group issue. If you're not able to make an RDP successful, security group issue. Why? Because we are not using any kind of customized NACL. We are using default NACL. So the overhead of NACLs is taken away from you. So you're only focused on security groups. So let's say you're trying to do a connection to an instance, which is a cloud instance. If it is a Linux machine, if you're not able to do an SSH, that means the issue is at the security group. There's a Windows machine. You're trying to do an RDP. You're not able to do it. That means it's an issue with the security group. So people, will you have issues with regard to the outbound rules of your security group? No. What are the issues that will exist? Issues will only exist at your inbound rules. So people, can I get a quick confirmation in the chat window that you people have understood the idea of security groups versus NACL? Can I get a quick confirmation in the chat window, people? Rahul says yes. Bintu says yes. Sheza says yes. Thank you, people. Now, before I go ahead and drop for the session, one more security group I need, because now I've created web servers for my web server security group, web server security group for web servers. Now it is time for me to create the database. So I'll create another security group because I need my database also to have a security group. So I say my VPC for DB, for database security, for the database instances. This security groups allows inbound traffic from public subnets. Am I right? It should allow traffic from public subnets only, because that is the source and that is the destination, right? 1 and 3 are the source, 1 and 3 are the destination. So I'm just mentioning from public subnets. So my VPC and add a security group. Clear, people? So now I've written a security group which is for my database, for the database security group. They allow traffic from subnets. So I'll follow the same rule. So edit inbound rules, add a rule. So I'll say here, okay, please allow all traffic. From where should I allow all the traffic? From public subnets. What are public subnets? To a public subnet. So it is 192 series.168 series.1.0/24. Am I right, people? Because that is my public subnet. And also allow the traffic, saying that allow all the traffic that should come from 192.168.3.0/24. So 1 and 3 are the source, 1 and 3 are the destination. This is the request and this is the response. So both the source and destinations are 1 and 3. So my job is done. Save the rules. Should I worry about outbound rules, guys, for security group? No, if 1 is allowed, 3 is allowed, outbound rules will allow this traffic to go with 1 and 3. Clear, people? I'm allowing all the traffic that is coming from 1.0 and I'm allowing all the traffic coming from 3.0, both the subnets. That is the source and that is the destination. Can I get a quick confirmation in the chat window that you people have understood now the idea of database security group? That means tomorrow if I provision a database, I'll put this database security group to my database instance. I'll start a machine and I'll get the access to that database machine. Clear, people? Now, whatever the rules that you have written, now it's time for us to do a test. Testing in the sense, now I need to start provisioning servers, which is the topic for EC2, Elastic Cloud Compute. And that is what we will do for the next session. Now we have set up our VPC. So once this VPC is set up in your systems as well, so people please provision this VPC in your systems now. Security groups, NACL into your systems now, or latest by tomorrow. And in the next session, I'll show you how to provision a machine and how these security groups and NACL play an important role for your connections. With that, guys, we come to the discussion of NACL and security groups targeted for today's topic. These are not chargeable, right? Very much, yes, they are not chargeable. NACL security groups are not chargeable. The chargeable resources that you majorly come across are your Elastic IP addresses, people try remembering this. NAT gateways, peering connections, gateway, VPN. So these are your chargeable resource instances. Your VPCs are not charged, subnets are not charged, route tables are not charged, internet gateways are not charged. Your elastic IP addresses are charged. Your instances are charged. Your VPNs are charged. Your peering connections are charged. Try remembering this. NACLs and security groups, you won't be getting charged for them. So, can I get a quick confirmation from all of you people that you will be getting these things done earliest by tomorrow? Your security groups. I'm only asking you to create security groups. Now, if you're making any changes at NACL, then there is an impact on security group. Let's do one thing. Let's try attempting this scenario in tomorrow's session, that if you make any change at NACL, does this make an impact on security group? Let's achieve this scenario in tomorrow's session. So I'll make change in NACL. Let's see what does the change that it bring to security group. Clear, Rakesh? Fair. So with this, guys, I bring to the closure of the session for today's topic. I'm going to stop the recording as well.